So you've made it past some of the low-level Objective-C work. It's time to come back out and start doing a few more things with graphical programming. Graphical stuff kind of starts with UI views. So today we're going to talk about some of the view properties. We're going to do a demo app to explore some of those properties. We're also going to explore some basic animations. So UIView is probably the most important class on the iPhone. I mean, there's a lot of things you could say about that. Probably UIView controllers is where you spend most of your time programming. But there's a real argument for saying UIView is the most important because it's everything that's visible, outside of some OpenGL things, is a UI view. So UIView, you can see here, they get stacked onto the hierarchy. So here we've got a window. A navigation bar is a type of UIView. A tab bar is a type of UIView. Then this is a custom view, and they kind of go together in these layers, and these views make up what you can see, but they're all actually UI views or UIView subclasses. There are a ton of different classes that are subclasses of UIView. Probably on the video you can't make out this full list, but you can see that there are a lot of them, right? So things from pickers and scroll views and alert views and action sheets down into the controls, the buttons, text field views, things like this. Labels are also a different type of view. Lots and lots of UI views. Before we get started talking about views, let's go ahead and talk about a little bit of background things. First is getting a handle on the structs that are used to define where the view is at on the screen. So let's start talking about those. First, we'll start by mentioning the CG float. CG float just stands for Core Graphics Float. Turns out that float is actually the exact same as a CG float. They're identical. One is type def, does the other. But they do this just in case they ever need to change it to like a different size. So if it needs to become a double, they could just change what CG float is. So everything you do with Core Graphics will use CG floats. The structs that are important to you are a CG point. That's the first struct you need to know about. A CG point is a struct that has two fields. I'm going to assume you already kind of know C and you know how to make structs and you know what a struct is. If you don't, it's a pretty easy concept. It's just a collection of different variables, and then they have field names. So a point has two CG floats, an X and a Y. There's a CG size, which also has two CG floats, except for its are called width and height. And then there's also a CG rect. A CG rect is a struct which has two struct fields. So it's got a CG point struct and a CG size struct. The CG point is called origin, and then the CG size is called size. So if you wanted to get a rex like y value, you'd say, whatever the rect is, myrect.origin.x. Let's also go ahead and look real quick at how you make these things. So you can declare the struct just using a standard C convention. So there's no alloc in our init. If you just say CG point, my point, that creates space for your struct. These just live on the stack. They don't go on the heap. So there's no memory management with structs. It's just a fancy variable. To make life easier, to make structs, there is a CG point make, which returns a struct of type CG point. And so it would set the values to 100 and 200 in this case. You could also do it manually. You can make a point and then you can manually say my point.x is equal to 100, .y is 200. So these two lines do the same thing as this one, assuming that it's already declared. CG size has the same idea, so you can set the width and the height using the CG size make function. And then for a rect, which has both of these in it, you can say origin.x, origin.y, size.width, size.height, or you could use the rect make and do it all together. So a pretty quick little background there into getting used to the structs that you're going to need. The reason these structs are important is because they are used for all UI views. So all UI views, when it's trying to figure out where it should draw on the screen, is it's got a property called center. So this property called center is a CG point, And if you change its center, you move where it's at on the screen. It's also got a property called bounds. Bounds is actually a CG rect. Um, for most people, they really only care about the size and the height of the bounds because that'll determine like how big the view is on the screen. The reason it's officially a rect is because it's also got an origin in there. And the reason for the origin is for things that are scroll views. It's where it's important. So for example, a table view is a type of scroll view. And if you think about a table, it fills up like the whole window. So the window doesn't move, but the things that are inside the window move. And the way they deal with that is by changing the origin of the bounds. For what we're going to do today, and for most of the views that you'll use, the origin will just be 0, 0. So we don't really care about that. We just care about the width and the height of the bounds. There's also a thing called the transform. This determines rotation and a few other things. We'll get to this later when we get there. I also want to point out there's a calculated property. So these are the real ones, right? So there are IVARs for these, and these are the ones I'd recommend you use. But there's also a calculated property called the frame, and the frame is also a CG rect. The frame lives in the parent view coordinate system. So sometimes the frame's handy to use. We'll talk about it later. If the transform is the identity, which happens a lot, and you prefer to talk about the upper left-hand corner of the rect, the frame can be a really useful calculated property. So it's if you think about it, it's one of these properties that doesn't have an IVAR. So we'll show you a little bit more about the frame. Because we're going to start doing stuff with graphics, it's important to note that the upper left-hand corner is 0, 0, X goes across and Y goes down. This is different from things like OpenGL, which is bottom left, but this is how the coordinate system works. So we're going to use these concepts, and we're going to make ourselves a demo. So we're going to have some buttons where we can make some changes. We're going to watch this thing move. Then we're also going to have some labels that are going to update to show us how this view moves around when we change things. So without further ado, let's start up Xcode. Let's create a new project. We're going to do a view-based application. We're going to make it targeted for the iPad. So select those, and then go ahead and call your project UIView properties. I'll go ahead and make a new folder here. Week 5. So UIView properties. And it should go ahead and give you some of the basic stuff. Since we used a view template, we've already got our view controller. We've also got our zip file. Let's go ahead and start goofing around with the zip file first. We'll start laying out a couple things so we get a feel for how this app works. Some of the stuff is going to be like pretty standard low-level repetition stuff of making outlets and properties, but it's good practice for you. You haven't done it quite enough yet, so we'll just go ahead and get you some practice making things. First thing I feel like doing is I'm going to go ahead and make my background something other than white. So instead of using white, I'll pick a color. I've used this color recently, and I'll use it again. I just grabbed like a red. It's kind of a Rose-Hulman / Stanfordy red, my two alma maters. And let's start dragging some things on here. So let's go ahead and grab a navigation bar. Actually, you know what? Instead of a navigation bar, just because we're allowed to, let's grab a toolbar. So toolbars in the iPhone world can only go at the bottom, but an iPad, they said they can go at the bottom or the top. So I grabbed a toolbar just because, you know, I can. The one thing about toolbars, though, is if you click on their little ruler or hit Command 3, you can see that they automatically stay a certain distance from the bottom. But if you put it at the top, you should make it stay a certain distance from the top, right? So if you rotate, everything still looks good. And onto this, what we're going to do is we're going to put a bunch of bar items. So go into your library and just go ahead and type bar item. And we're going to drag out a grand total of 7 of these guys. So there's 3, 4, 5, 6, and 7. We want 3 of them on the left and 4 on the right, so grab a flexible space and stick it right in between there. And that'll make them positioned where I want them. And then we're going to name these center, bounds, and then we're going to have a reset button for resetting the center and bounds, a rotate, a scale, and a translate. The way this is going to work is the items on the left deal with the center and bounds, and then all of these items on the right are going to deal with the transform. So we got a lot more buttons for the transform than the center and bounds. In addition to this, we're going to make a few labels. So let's go ahead and go back over to the library and type enough to bring up the UI label, and go ahead and drop a label on here. I want my label to be white since I've got a dark colored background. And this first one is going to be my view center. And so this is going to describe my view center point. And so that's kind of the description. And then in here, we'll just kind of say, you know, like the center is going to be something of this format, right? So it's kind of a placeholder there. And then what I'm going to do is I select them both and I hold down Option. And if you Option drag something, it makes a copy of it, which is nice. So we've got a few labels that we're going to give names. So this one's going to be bounds size. Move things over a little, try to make it all fancy like. And then this bottom one we're going to make be the frame. And so for the frame, we're actually going to show all four values. So we'll show the origin and then the size as well. After that, we're going to show a few other things for the transformation. We're going to show an angle and a scale, so we can see what the transformation's angle and scale are like. And then you can go ahead and make something for them to control, and this is just going to be some number of degrees, and then the scale is just going to be a size, right? So it's just going to be a plain old number. Cool. So we've got a couple labels that we're obviously going to be changing, a couple buttons that we're going to be pressing, so we're going to need a grand total of 7 IB actions. Then we're going to need 5 IB outlets for the labels. And then last but certainly not least is the view that we're going to modify. So if we drag a view into here, go ahead and hit Command 3 to bring up how it gets resized. Make sure the struts are on for the left and right, but no others. And go ahead and make sure that you're modifying the center. Let's go ahead and set the center point to be 200. 300, and then the width we'll go ahead and make 100, and the height we'll go ahead and make 100 as well. So that's how this thing is going to move around. And then if you want to, you can make him a different background color as well. I'll just go with a light gray color or something like that. Gives it a good Rose-Hulman-y feel. Great, so we've got the the zip file ready to go, but now we need to make places to connect these things to. So let's go ahead and start making some places to make connections. So this is always kind of the tedious part, but it's good practice. So the first thing we've got is we've got a UI view. I'm just going to call it my view. And then we've got a label for each different thing. Because I like copy paste, I'm going to just go ahead and make something that I can copy paste a few times. So we're going to have the center label, should have given it a capital L, the bounds label, the reset, the center label, the bounds label. Actually, I'm going to call that one the bound size label because we're just going to show the width and the height. Then we're going to have a frame label, an angle label, a scale label. So those are our outlets. Since we're going to be connecting them in Interface Builder, we'll go ahead and make properties for them. We'll go ahead and use standard non-atomic retain, and then we'll say the IB outlet keyword so that it gives us something to connect. And then we may as well get the memory management citizenship over with. So we're going to have to do the other steps at some point. May as well do them now. So first we've got to synthesize them. This is going to give them a getter and a setter. The nice thing is that you kind of understand more about what each of these boilerplate codes do, right? So there's the synthesize step. Then after the synthesize, since these properties have the word retain, it means that there's a retain count on them coming from us. So that means that we need to release it in the dealloc. So we'll go and add the word release for each of these, and that will release them whenever this view controller goes away. And then since it's a view controller, there's that one additional step of in a big program, it might have to release your view. And in such an event, you should release all the things you have retains on. And the way that's recommended to do that is to change their connection to nil. So instead of being connected to whatever they were connected to, set them to nil. Anything that you can get back in view did load, you should go ahead and get rid of in view did unload. Great. So do a quick Control B just to kind of make sure things are compiling. So far, so good. Let's go ahead and connect these real quick. So go ahead and go back to your zip file. Let's start making some of these connections. So I'm going to drag from my file's owner to all these different things. So I'm going to drag to the center label, the bound size label, the frame label, angle label, scale, and then most importantly my view. So go ahead and pause the video, assuming that I was too fast for you, and go ahead and get yourself caught back up on the 6 outlets that we've got. Once you've got your outlets ready to go, let's go ahead and start adding some actions. So for the actions, we're basically going to have an action for each button. Again, because I'm lazy and I like to make my life easier. Oops, I'm just going to copy paste a few of them. So I believe that there were 7 total. So we have, if you press the center button, the bounds button, the reset, bounds and center. I'll be a little wordy there, just because there are 2 resets. We've got a rotate, we've got a scale, we've got a translate, and then we've got a reset the transform. So we've got these different actions that we're going to take place. And the purpose here is that these should kind of show you the changes that happen for a typical view that changes. Also, you'll notice that usually I stick on the ID sender. I know that I'm not going to use it this time, so I just don't even mess with it. So go ahead and copy paste these into your implementation file, and then we'll go ahead and put a little log message in there. The log message that I like to use is I just print up what function I'm in. There's a trick for that where you can just say log %s, and then you can say underscore underscore function underscore underscore. It must be in all caps, must look exactly like that. But it's a really handy way to just print out what function you're in for when you first are getting started, right? So save everything. Let's go back over to the Zib and let's make these button connections. So from center, make sure I've actually got the button. I can control drag and say that's press center. Bounds. reset the center and bounds, rotate, scale, translate, and then reset the transform. Cool. Go ahead and save it up and hit Command Enter. See if this thing runs and see if it does anything useful. I think I'd rather it be 100% so you can see it a little better. And so the first thing we want to do is we just want to make sure that all of our buttons are really connected. So if we say center, it should print out the right thing there. Bounds, reset center and bounds, rotate, scale, translate, and reset transformation. So all of our actions are set up. We'll make sure all of our outlets are set up when we start actually manipulating things. Go ahead and pause the video and make sure that you've got all of your actions set up. Alright, so let's go ahead and keep on trucking. So all of our actions do something, that's great. One of the things that we're going to do throughout this app is we're going to be updating the labels. So let's go ahead and make a function called update labels where we're going to go through and we're going to set all the labels. So the labels all have text, and just kind of to make sure that we're connected, we'll start off and we'll set each one to a blank label. So we've got a bound size, frame label, an angle label, scale label, and so we're going to be setting them to something real, but for now I'll just kind of blank them all out. And what we're going to do is after each of these functions, we're going to do stuff for it, and then we're going to update the labels. So I'll just go ahead and stick that in all the functions real quick, because I know at the bottom of every function I'm going to want to update those labels. I'd also like for them to start off updated. So inside ViewDidLoad, I'll go ahead and stick one there too. And let's go ahead and run it and make sure our labels are connected, and we can see that it got rid of them all, so it must have set them, right? Cool, so let's go ahead and start making a couple changes, and let's see what happens. So the first thing that we're going to play with is we're going to play with moving the center. So for this, what we want to do is we want to say CG point, and then we're going to make a variable called new center. It's a struct of type CG point. And what we're going to do is we're going to grab my view center. So there's a property called center. The way you know this is, for one, you could believe me because I'm telling you the truth. But if you don't like believing people, you could always look it up and help. You could look up things about the UIView, and you could see that there is in fact a center, a bounds, and a transform, and then frame is actually just just a synthesized, or not a synthesized, but a property without a real iVar. And so center is a point, and so we're going to grab it and we're going to store it off. And then I'm going to say new center X. Let's just go ahead and move it over by a good amount. Let's move it over 30 pixels in the X and 50 pixels in the Y. And then what we're going to do is we're going to write it back. So we're going to say the center is the new center. Cool. So what this is going to do, it's going to save off the center. You're going to modify it a little bit, then you're going to write it back. One of the first things that people ask when they see the syntax is, why didn't you just do this? So I kind of thought the same thing. So you could just do this for one, and then you could just do this for the other one. Why on earth did I do it this way? Why didn't I just do it with these two lines of code, right? We'll try to build it real quick, and that'll probably tell you your answer. L value, so the left value, is not valid for assignments. So that's why we don't do it. To understand why this fails, you have to think about what this is doing. So self.myview.center, what that does is that expands to something, right? And so what it actually expands to is it expands to self.myView center, and then from there it's trying to grab the x value, and then it's setting equal to something. And the reason that this is problematic is whenever you put properties on the left of an equal sign, it's actually wanting to make a setter call, but you're using it as a getter here, and then you're getting a field of the struct. So the reason this causes a problem is because this dot x is getting the field of a struct, whereas these are doing things with properties, and it causes trouble, right? So don't do that; it fails. So we're going to do it this way. So this is going to move the image around, so you can run it at this point, and when you click on it, you can see it changes the value of the center, and it moves it on its way. Cool, so that's kind of exciting. Reset does nothing, of course, and the label is blank. Let's fix some of those things. So the first thing I'd like to fix is I'd like to fix the label. So let's go ahead and do that. So let's say its text is equal to ns string. We'll just go ahead and make a string with format. The format I said I was going to use was a just kind of making it look like a point. To highlight the fact that it is actually a float, I'm going to go ahead and put 1 decimal in there. And now here we can say self.myView.center.x. That's totally fine because it's not like the left value of something. You could also, if you really prefer, to think about what it's doing is it's calling a method on self, getting the myView property. Then it's calling a method on whatever is returned from that, and it's calling the center property. And then what that gives you is a struct, and from there you're grabbing its.y value. Most people go with this style, right, because it's easier to look at, but it is important to realize that some of these are methods and some of these are fields and struct, and they're all kind of different. So that is the center. So if you run it now, you can see that the center should hop along. So it started off at at 200, 300. Then every time we click, you can see that it moves along its merry way, which is kind of fun. Even after it goes off the screen, you can still keep on clicking. If that excites you, feel free to go nuts. Let's go ahead and print out a couple more things while we're at it. We'll move the bounds first, then we'll print out some more things. So the bounds, what we're going to do here is very similar. Bounds is not a point though, it's a rect. So we're going to say cg rect new bounds, and that's equal to self.myView.bounds. And then new bounds, we're going to modify the size.width. Since it's a rect, it's got a CG size in there, so first I grab its size, and then from that struct I grab the width field. Here you can see we use ... because it's going into a struct, which is just fine to have on the left side of an operator. And we'll just go ahead and make it bigger. We'll just do the same 3050. So we'll modify its width and height. And then once we've made the new CG rect, we can just write it back. And so we can say new bounds. And so this is totally fine to do. What this is really doing under the hood, if you want to think about what it's doing with methods, is it's doing this. So in terms of methods, this line right here and this line right here are identical. So one is just doing the same as the other. So that's why that's legal. And let's go ahead and print it out. So no reason to have this on here. So we're going to print out very similar format. We're going to print out two values. Here they're actually size or width and height. And so we're going to print out the bounds dot width, and then we're also going to print out the oh sure, I'll leave it in the function form. we're going to print out the bounds dot size dot height. So you can see this is where it transitions from method to field, which is just kind of wacky. And then while we're at it, let's go ahead and print out, let's run it real quick and see this work. Oops. Looks like I forgot the word size somewhere. Now bounds.size, because this is a rect. It's got a field which is a CG size. The CG size has a field which is width. And now I can move the center, and you can see that the center updates. And if I increase the bounds, you can see the label changes. Maybe I should make that font bigger for the video, but you should be able to see it on your screen just fine. And so now the bounds keeps getting bigger. The center I can move. Reset still does nothing. Eventually the bounds will get too big, and you'll wish that you could reset it. Cool, so let's go ahead and keep plugging along. What I'd like to do next is I'd like to go ahead and print up the frame label, just so we can see what's happening there. So this one, we're going to print up two things. We're going to print up its origin, and then we're also going to print up its size. So we're going to self.myView.frame. We're going to print up its origin X, and then we're also going to print up its origin Y. After the origin X and Y, we're going to print up the size width, and then the size height. So you can see that the frame has four things we care about, the X and the Y's, and then also the width and the height. You should be able to see a strong correlation. Oh, it's too small. Let me go fix that in the zip file. Should have seen that coming. So it stretches to fill the box, and the box was a little too small. Tell you what, we'll just make the box real big, and then it'll size however much space it needs. So you can see that there's a really strong correlation between the top two in the synthesized frame. So you can see that the bounds, width and height are 100, 100. The frame has the exact same width and height in this case. So long as the transform is the identity, that should always be the case, that these things match. And then the center and the frame are different because the center is based on the center point, right, which you'd expect. So this is 200, 300, right in the middle. But when the frame is being discussed, they actually talk about the upper left-hand corner. So you can see it's 50 less because that's half the width. And then also in the Y, it's 50 less because that's half the height. So the frame talks about the origin being the upper left, the width, and then the height. And if we move it, you can see that the frame updates just like you'd guess. And if it gets larger, the bounds and the size of the frame go together. The reset button still does nothing though, so it'd be nice to make that work. So let's go ahead and make the reset button work. So inside the reset area, what we'd like to do is, we'll show you a quick way to do it, then we'll show you a better way to do it. So we want to say my view center is equal to CG point make, and it started off at 200, 300. You can just type 200, 300 and that's fine, or you can put an F and that'll make them be floats. Or the thing you'll see some people do is they'll say 0.0, which makes sure it's a double or a float, and then the F makes it a float. It honestly doesn't matter. I don't even think there's a performance difference even at the lower levels. And so if we wanted to reset this thing, we could say make it center, be that, and make a bounds with a 0, 0, 100, 100. So inside center, we move it, bounds makes it bigger, and then reset will snap it back. So this works just fine, but I'll say it's kind of a shame that we've got these numbers typed in here because they were also typed into Interface Builder, right? And what if you changed Interface Builder, then you'd have to make this match. So it might be nice to actually go ahead and save off these values in ViewDidLoad. Then we can load them back later. So let's just go ahead and save them off. So we'll just go ahead and save off a CG point for the initial center, and then also a CG point for the initial bounds. So if we save these off, we'll just grab the self.myView.center, and then also the self.myView.bounds. And then once we've saved them off in ViewDidLoad, if we ever want to reset them, I'll go ahead and just comment out these top two because it's good to know how to use CG point rec or CG point make and CG rec make. But now a slightly better way would be to just save off whatever it was when you first made it. And that way you've lowered your dependencies, right? So if you change it in one place, it'll just kind of change it everywhere. So if we see this in action, oops, incompatible type. What did I do? Incompatible types. I must not have made it. No, CG rect. Must be more careful. So you can see that it does the same thing that it did just a second ago, but now we're prepared for a future where if we ever change the zib, it'll only change in one place. Another thing that you'll notice is that it kind of leaps from one spot to the next. So it just magically gets there. If you hit reset, it just like snap and it's back. iPhone programming is all about making things look smooth, right? So if I hit reset, it'd be nice instead of magically snapping back if it kind of like did a smooth transition to get to there. So let's go ahead and do that next. So this is the introduction to animations. So let's go ahead and add some animations to these. The easiest animation you can do, let's play with reset because that'll be a fun one to play with, is you can call a function on the UIView class called begin animations. Let's go ahead and look at that just real quick. So there is a function called begin animations. The way this works is it's a class function. You can see it's got a plus symbol here. You pass it in. You can pass it in an animation ID if you would like. If you don't need it, you can leave it nil. We're going to leave it nil. It's only useful if it's a more complex animation. You can also pass along a context. All the context is it's just an object that gets passed along with the animation. We don't really need either of those, so we're just going to say nil nil. So this begins an animation block, and then it's going to animate anything that's inside of it. So we want to animate it up to here. Whenever you're done with the block and you want it to start happening, you can say UIView commit animations, and that will commit them, and then the animation will start happening. So let's see this in motion. So we move the center, it still leaps, the bounds leaps, but if we say reset, you can see it does a little animation, right? Which is pretty cool at how easy that was, right? So it does a little animation coming back. You can control a lot of things about the animation. The first one that we'll play with is you can control how long it takes. So if you just look at the view with animations, next time we'll play with the block stuff. We won't worry about that just yet. You can see that there are a lot of things you can change. So you can change some things like when it's going to start, if you want to ever disable, enable animations. These we'll get to later. The setting delegate callbacks for like when it finishes and when it starts. You can get it informed when it finishes. That one's really useful. Duration is the one we're going to play with now. The duration lets you decide how long it takes. So if we say UIView set animation duration, if we want it to take 3 seconds, don't really need the F here, then it'll just do that over 3 seconds. So if I hit reset, it'll kind of slowly come back now, which is kind of neat. So let's go ahead and stick these on some of our other functions, just so that we've got them. So on the bounds, and also on the press center. So stick in the begin, and then also stick in the commit. And I grabbed the 3 seconds as well, just so you could kind of like see it happening, right? So now it transitions and you can see it, and the bounds increases and you can see it animate up, which is pretty neat. One thing I don't like though is if you hit center a couple times fast, so let's say I hit it like 1, 2, 3 times fast, you can see it kind of like lurched, and then it got there. Same with bounds. If I hit it like 3 times fast, you can see it kind of snapped through, then it animated the last one. There's actually a setting that you can do to change things like that as well. It is called begins from current state. So there are a few other things that we skipped over, but you can learn about all of them as you see fit. But begin from current state's one that I think would be handy here. Also, instead of copy pasted, I'll show you that it's really handy that they all start with the same words. So you can say UIView set animation, and then you hit the escape key and you can see all the different options, right? So we want to say set animation begins from current state, and if we say yes, then it won't ever lurch. It'll just start from where it's at, and it'll make it go faster if it needs to catch up, which is kind of clever. So now even if you hit center like 1, 2, 3 times real fast, you can see it never lurches. It does kind of get faster. If I hit bounds like a whole bunch, there was never a lurch, which is kind of nice. So we've seen animations in action. It's amazing how easy they are to do, and to do well, right? So really easy changes, really simple code, really slick little animations. So let's keep on chugging. Center and bounds, people typically understand those pretty quickly. The ones that get a little bit harder are these transformation matrices. If you were to survey iPhone programmers, most of them would have this stuff down cold. A bunch of them will have never messed with the transformation matrices. And there's some neat things that you can do, so I'd like to talk about those. Just kind of real quick, we'll hit the slides. The transform property is a CG affine transform struct. In your head, you should probably think of the CG affine transform as a 3x3 matrix. If you're used to 2D matrix work, you'll know that a 3x3 is how you can rotate, scale, and transform something. Even though it's a 3x3, the struct only has six fields in it. And that's just because it knows that this final column should be 0, 0, 1. So these A, B, C, D are used for rotations, and they're also, you can do some weird skewing things that we're not going to do. And then the TX, TY will help determine position. You don't actually care how this works under the hood, to be honest, because typically what you'll do is you'll use functions to make these different affine transforms. So we're going to teach you about make rotation, make scale, make translation, and then some different ways to do it. So let's go ahead and make use of these functions, and let's make some changes to press rotate, scale, translate, and reset. Since it's going to be pretty much the same in a lot of ways, I'm just going to go ahead and copy from above because I really like my animations. So now I've just kind of got my animations and I'm ready to make some changes. So what I'm going to do here is we're going to have a variable called angle that we're going to increase. So angle is just going to be an IVAR. We're just going to go ahead and make it be a CG float called angle. There's really no reason to make a property for it because properties are useful because they help you deal with memory management, but there's no memory management here because it's a primitive. They also make things publicly available, which we have no need of that. And they let you use the dot syntax. We don't need any of those things, so there's no need for a property. So we're going to take our angle and we're going to increase it by 20. If you don't set it to anything initially, it automatically defaults to 0, which is fine with us, so there's no reason to set it initially. And what we're going to do is we're going to say, hey transform, you are equal to CG affine transform make. You can start typing it. You can type the whole thing if you want, but you can also hit the escape key and try to find the one that you want. We want to make rotation. And all rotation takes is an angle, which is nice. But then there's the question of, is that angle degrees, is that angle radians? And the way you answer these is by holding down Option, double-clicking on it, and looking it up in the help. You can see real quick that it's in radians, so it wants an angle in radians, which is probably what you would have expected. So I prefer to think in the world of degrees, so my angle is going to be in degrees. But then before I call this function, I'm just going to change it to radians real quick. So I'm just going to divide by 180, multiply by pi. Pretty simple little math. So this is going to cause it to move. Let's go ahead and update the label while we're at it. Label is going to be pretty easy to update. So we just want to say it's a string with format percent 0.1f degrees. And we just put in the angle. Cool, so let's go ahead and see if we've done anything useful. So we can move the center and the bounds just like before. And now if we click on the angle button, you can see it already printed something here, that's good. Click on the rotate button, we can see that it moves to 20 degrees. And it actually took the view, moved it to 20 degrees. If you click on it again, you can see it'll take it over to 40 degrees. Our animations are still working slick, which is awesome. And something interesting happens if you look over here. The center did not move. So if I hit reset, you can see the center stays as I rotate, which is no surprise. The bounds does not change, but the frame does. So the frame, if you're not using the identity transform, the frame is pretty much worthless. What it does is it figures out what is the smallest rectangle that will fit the current configuration. So you can see frame quickly becomes worthless when something is rotated. But pretty neat little trick we've got here. So we've got the ability to rotate this thing. We've got a way to make cool little animations for it, which is slick. And we haven't lost any of our other features, which is cool. So let's go ahead and do some more. So this is rotate. Rotate is probably the most important transform because it's the one that you couldn't do over here. There was no way to rotate over here. The next two, scale and translate. Scale is really similar to changing the bounds, and translate is really similar to changing the center. But it's handy because it's kind of done in a different way. So let's go ahead and do those things. So let's go ahead and take what we did in rotate. And we'll copy it in to scale. It's similar in a lot of ways. It's an animation. We're going to be changing an IVAR. I'm just going to make one just called scale. So it's also a CG float scale. And what we want to do is we want to make the scale 10% larger. So we're going to take whatever scale was before, multiply it by 1.1, and that'll just make it 10% larger. In order to make a transform, it's actually just CG affine transform make scale. The scale actually takes two parameters, and the reason for that is because you can scale the x and the y separately, but for our purposes we're just going to scale them the same. I-vars that aren't set initially get defaulted to 0. Defaulting to 0 would be bad, right? Because multiplying 0 times 1.1 wouldn't do anything. So let's go ahead and in our viewDidLoad, let's go ahead and set scale to be 1.0, just so that it's got an initial value. I'll put the F1 for efficiency reasons. Doesn't really matter. So if I try to run this thing now, and we click on scale, you can see that it should get larger. It's kind of slow about getting larger. So every time we click on scale, it gets a little bit larger, which is kind of neat. You can see that the scale does not affect the center. It does not affect the bounds, which is kind of surprising, right? So changing the scale has no impact on the bounds, which is neat. It does, however, affect the frame, right? So once something becomes no longer 1:1, the frame is pretty much shot. I forgot to change my label, so let's go do that real quick. So if I grab what I did for degrees, this will be pretty similar. So this is just going to be scale. We won't print out anything, we'll just print out the number. We'll go ahead and print out a couple more digits for scale, though, just for giggles. So you can see that scale right now is 1.0. When I click on scale, it gets 10% larger. When I click on scale again, it gets 10% larger than that. Scale again, 10% larger than that. Bounds never changes, frame does. There's one shortcoming to what I'm doing right now, though, and that is if I click on rotate, what rotate's going to do is it's going to make a brand new transform. So even though my scale is big, right, if I click on rotate, it's actually going to go back to the original size and rotate it 20 degrees. Likewise, if I click scale, it's going to make a brand new matrix, so it's going to be unrotated. But you can see it did increment from where it was at before. So this is what you should have expected. And that's because this function, CG_AFFORM_TRANSFORM_MAKE, is it starts with the identity transform, and then it applies, this angle. Same with this one, starts with the identity and applies some angle. So what we'd like to do in this case is we'd actually like to use a new function, and you can look up all these functions by typing in CG_AFFINE_TRANSFORM, and there should be a little AFFORM transform reference guide. I'll just go ahead and click on one of them in here. So CG_AFFORM_TRANSFORM reference. You can see that there's a bunch of different functions. And you can see that under the hood what make rotation is doing is it's actually making this matrix right here, which you can see there's no way it knew what the scale was. So the function that we actually want is, instead of make rotation, we just want rotate. So rotate receives an existing transform and it modifies it. So that's the one we kind of want for this case. So here we're just going to say self.myView.transform is equal to CG_AFFINE_TRANSFORM rotate, and we have to pass it something in this time. So we're going to pass it in the existing transform, and then we're going to pass in how much we want it to rotate by. Note that this time it's different. Instead of passing in the absolute value, which is what we did before, we pass in how much we want to change it by. It is still in radians, though. And so we're going to go ahead and multiply it out so that we get the appropriate value. I went ahead and stuck on an F just to make sure it didn't do integer math. Technically I could get rid of the 0.0 if I wanted, but I want to make sure that it does floating point math and not integer math. So we can fix that one up. Likewise, we can do a very similar task down here. So we can grab the transform and apply a CG aform transform scale, and it's the same as it was before. You have to pass it in a transform, and then however much you want to change it by. So here I'm going to say 1.1 because that's how much I'm going to multiply it by. So I don't say scale, I say how much I multiply it by. So let's see if these things do things the way that we like. Nope, it didn't like that. I guess you do need the 0.0f. I thought it'd be fine. Live and learn. So when we run this thing, what we should get is we should be able to rotate it. And then if we increase the scale, it should stay rotated, which is exactly what we want. So now they kind of behave nicely together, which is cool. You can see that the center and bounds don't change. Frame kind of goes nuts after a while. And it's a fun little game to play with, right? If you click rotate enough, you can probably get it to freak out. So if you click it like 10 times fast, it will eventually, it'll get there however it's fastest. So I kind of made it rotate the other way, which is nutty. Cool. So let's kind of keep going here. So scale is a way to change the size without actually affecting the bounds. We should go ahead and work on resetting and translating. We'll go ahead and do it in order. We'll translate next. So the next thing we want to do is we want to translate. So we're just going to grab what we had done with scale. And we're going to bring it over, but we're going to say instead of scale, we're going to say translate. We won't even mess with the in-between step. You can see that this takes transform just like before, and then however much you want to translate the x and however much you want to translate the y. What we're going to do is we're going to translate the x only because I want to show you something. So this is going to translate by 50 in the x direction. And so if I click on translate, you can see it moves it over, just like you'd guess. Now the real question is, if I rotate it, and now if I click translate, which way is it going to go? Is x going to go this way, or is x going to go that way? You can click it and find out. The rotation is observed, and so now when I move in the x direction, x has changed, right? So you can see that translate is a lot like center, and that you can move the thing, but it does work differently, right? So it moves with the rotation. And you can think about how in a game that might be really handy to be able to know that fact so that you can move around inside your new orientation. So these things should behave nicely together. But if we could reset, reset doesn't do anything yet, right? Let's go implement reset real quick. So reset, I'd like to animate it just like all the others. So I go ahead and steal the animation blocks. But this time what I'm going to do is I'm just going to set the transform to be equal to CG transform, and if we just want to bring it right back, there's a thing called a built-in constant called the identity. So we're just going to set the transform equal to the CG affine transform identity. And then because I want my angles, or I want my labels to look right, I'm going to reset the angle and the scale. So I'm just going to make them back to an initial value. So now if I run it, I can rotate, I can scale, I can translate, and then if I hit reset, it just puts them all back, which is pretty neat. So I can change a few things here, a few things there, and I can reset independently, right? So I can reset that one, and then I can reset the center and bounds. Pretty neato. Let's go ahead and do just a couple other minor things. The first thing is you can see that this is a UI view This is a UI view with nothing on it, and this is it's actually a UI view instead of a subclass. You can actually use I mean, things that are subclasses of UI view the same way. So if we got rid of this guy, and instead we put on, what's a fun one, stick on a segment controller, and then we connect him and we say, you, my friend, or my view, save the changes to the zip file, and you can see that we can move other things that are subclasses of UI view. And it's a segment control. It works just like it does. You can rotate it if you like. You can click on a rotated segment control. Probably something you will never get a chance to do, except for apps you make yourself. You can change the scale if you want a great big button. This is just to show you that it's possible. This is not recommended, but it's kind of neat, and you can reset it. And you can put it back to where it was. So anything that's a subclass of UI view, well, most things that are subclasses of UI view have all these things that work the way you would expect. Some have a few things you wouldn't expect, but they're all pretty simple to use. So that's kind of neat. Now, to be honest, segment controls aren't practical, right, to move around like this. But there are some UI views that are really practical to move around. So there are a bunch of games that are really just buttons that fly around. We're going to do an example with that later. But the one that's most popular is UI image views. So let's go ahead and change this to a UI image view. Obviously, we could do it with the zip file, but just so that we get a little practice, let's go ahead and do it in code. It'll be fun for us. So we're going to make a UI view. So a UI view holds an image. So let's go ahead and get an image. So let's go ahead and get an image. There's one on the course website. If you go to today's date, or where you got the video from the calendar, there is a zip file called rlogozip that goes along with this video. So if we go ahead and click on that zip file, you can click on it, and it will download it. And then if you extract it, you can see that there are two images in here. There's a .jpeg file, which is big, so it's a 187. And then there's a PNG version, which is a 57 by 57. Obviously, I was using this for an icon once upon a time. So there are many ways to bring it into the project. The one I usually use is Command Option A to bring something in. You also right-click and you say Add Existing File. But the one a lot of people use is the good old drag and drop. So you highlight them in Finder, you drag them over, and then you say Copy In. Now you've got them in your project. So what I want to do here is I want to go ahead and make a new UI image view. So I'll just call it New Image View for now. And what this is going to do is this is going to use a UI image view alloc. And the init we're going to use is actually init with image. So there's a convenience thing called init with image that will let you make an image view using an image. And then the easiest way to get the image into the program is to use the UI image view convenience method called image name. So we want the image named r.png. If we make it, that's all well and good. But if we just make it, it's just on the stack, right? And so we made it, but you can't see it. It's not visible. If we want it to be visible, we would need to say self.view, add the subview, new image view. And so now you can see that it's visible. So that's good. It's now part of the screen. You can see it put it in the upper left because we didn't say where to put it, so it defaulted to 0, 0, so it put it in the upper left. You can see, though, that it is actually the right size. So this convenience constructor makes the bounds match whatever the image is, which is kind of neat. You can see that by switching it to the JPEG, which is a different size. And you can see that that makes it bigger to fit with that size. But of course the segment controller is still on here. We don't really want that. So let's go ahead and do some other things. We want my view to be set to new image view. So we want it to be my view. Once we set it as a property, that increases the retain count. So we can say new image view release. So now only the property has got it. And at this point what we can do is we could run it. And if we click on these buttons, we can see that it's now the one that is getting changed. Now, of course, the segment control is still on the screen, which we don't really want. So let's go ahead and change that. So if we want to get rid of the segment control, what we can do is we can remove it. And so at this point, like when it first comes in here, my view is pointing to the segment control. So if I say remove from super view, it's gonna throw the segment control off. And then here we're switching it to point to the R logo. So this will make the segment control not be on the screen. Now there's also the question of memory management, so it's no longer on the screen. There's also the question of memory management. Did that get handled correctly? So it's kind of interesting that the segment control actually had a retain count of 2, 1 from being a property and 1 from being on the screen. When you remove it from the super view, that brings it down by 1, so its retain count would only be 1. And then when you assign my view to something else, it'll bring that segment control's retain count down to 0. So things are starting to go pretty well. Let's go ahead and do one more thing. Let's go ahead and set my view center. We'll just go ahead and use the same one we did before, 200, 300. That seemed to work all right. And so now it should start off at 200, 300. You can see its bounds is whatever the image was. So it must have been 187 by 216. You can surely prove that to yourself if you really want. 187 by 216. Indeed, it matched. Kind of figured it would. And you can do everything that you did with it before, right? So you can move its bounds, you can move its center, and it works just like it did before. You'll notice that with the bounds, it's stretching to fill the rectangle, which may be what you want, maybe not what you want. But we're going to talk about the fact that it's stretching and how you can make your own choices about what it should do. Kind of neat to watch the image animate. You can see it works super slick, just like you'd hope. The reason it's stretching is because there's a property called content mode. So the property called content mode is on a UIView, and content mode, the way it works, let's go ahead and scroll down to content mode. Where I must have overlooked it. Content mode right here. It is of type UIView content mode, which is just an enumerated type. So the content mode decides whether it stretches or whether something different happens. So let's go ahead and let's just see a couple of the content modes in action. Here's the complete list of what the content mode might be. It defaults to scale to fit. You could also make it aspect fill. So what aspect fill would do is it'd keep the same aspect ratio, and it would always fill the rectangle no matter what. So it would always make a filled rectangle. This can actually be a pretty good option sometimes because it's keeping the right aspect ratio. There are a couple downsides, and that is it guarantees to fill. Now what that actually means is eventually it might start to lose part of the rectangle. So another thing that you could do, so that guarantees to fill, another thing you could do that I think is probably the one that I would use here is aspect fit. So this guarantees to keep the aspect ratio, and it guarantees to fit into whatever size the UI image view is. Just so we can see this a little better, let's give it a colored background. Let's give it like a blue color. So anywhere there's UI image view but not image, it'll be blue. So like if I click bounds, you can see that the image view is a little bit bigger than the image, but it just uses the space that it has to fit the image, and it guarantees that it'll maintain the same aspect ratio. So I think that one is useful a lot, just because I like keeping the aspect ratio. So this is this is your introduction to UI views. We've seen a lot of their different properties. We've also seen how you can animate them, and some of the neat things that you can do. Animating UI views, changing their center, changing their bounds, changing their angle, changing their scale, and then also the different things that you can use as UI views for your own animation purposes. Cool, so that's all we've got for today. Next time we're going to talk more about animations. We're going to get a little bit of practice with animations and look at them a little bit more in depth. Cool, see you next time.